In system.rs, your palette should more or less look like this. With the block number getter, which just returns the block number, then the increment block number method, which increments the block number by 1, and the increment nonce. Here, as previously we've seen with B-tree maps, we first get the value for who, and if it's not present, we default to 0, then increment by 1 and insert it back. Now you might ask yourself, what the heck, why do we just add up these numbers and add 1 to the nonce? So let me explain you this. If we, the block number is of type U32, and if we now assume that a block is being produced every 6 seconds, this would mean that we would wait 817 years until we reach the upper boundary of this block number space. Now the same is true for the nonce. A user submits a transaction which incurs cost to increment it by 1. So it would be just economically not feasible to make this nonce go overflow. So for the sake of a simpler API, you could just leave it out, and to mimic Polkadot SDK, because they have chosen to just simply add up these numbers, like I've said, for the sake of a cleaner, simpler API instead of using safe math. But if you've chosen to use safe math, it's perfectly valid as well. The last thing is our test, the init system test. Here we create a new system palette, increment the block number, and then increment the nonce for Alice. We go on and check if the system block number is now 1, as well as the nonce of Alice is now 1. Finally, we check that the nonce for Bob gives us none because Bob hasn't sent a transaction yet. So if we take a look, this is a B-tree map, and the get can just return an option. Since Bob doesn't exist, it's none. Now that the system layer is functional, we are ready to integrate this into our broader runtime. Let's move on.